Sorry about that. I'm not exactly sure where my last video cut me off, but I think it's somewhere around here because I saw it out of the corner of my eye when it stopped. So we're back here working with this tension problem, and I have set up my T1 vector to be in terms of the magnitude of T1 and cosine and sine of the angles for the x and y components. And I've also set up my T2 vector in terms of its magnitudes and the cosine and sines of the angles. And I was talking about the weight vector and how the weight is going downwards, so it has a negative vertical component of 100, and the horizontal component is 0 because there's no force in the horizontal direction. I talked about how the sums of the vertical components of T1 and T2 hold up 100 pounds of force. So that idea there is that when we look at our vertical components, we should see like the sums are equal and opposite to the weight of the force, the 100-pound force. And then the sum of the horizontal components of T1 and T2 should even out, okay? So let's just see what that means. When I write these up in 1 and 2, I'm just giving us some verbal description of what's going on. But really, we are looking at the idea that if we were to add T1 plus T2, it would give us a resultant vector. And that resultant vector would be equal and to the opposite of the weight that's pulling down. Okay, so like the wires are pulling up, the weight is pulling down, they even each other out. So equal and opposite. And so just using that alone, that equation alone, I can come up with an algebraic statement that summarizes what I wrote in 1 and 2. So writing this out, I have T1 plus T2. The x component will be the magnitude of T1 times cosine of 140 degrees plus the magnitude of T2 times cosine of 32 degrees, comma, the y component will be the magnitude of T1 times sine of 140 degrees plus the magnitude of T2 times sine of 32 degrees. That closes up my vector. That's T1 plus T2, and this is equal to the negative of 0, comma, negative 100. Okay. So using the equality of vectors on either side, the x component on the left side must equal the x component on the right side. So the x components, or the horizontal components, those are going to give me the magnitude of T1 times cosine of 140 degrees plus the magnitude of T2 times cosine of 32 degrees is equal to 0. The y components, also known as my vertical components, those are going to give me the magnitude of T1 sine of 140 degrees plus the magnitude of T2 times sine of 32 degrees is equal to a positive 100 after we distribute that negative sign. And so this gives us two equations, and it looks like we have two unknowns. Those unknowns are the magnitudes of T1 and T2. I'm going to call these A and B. So in A, we could solve for T1 or T2. I'm going to solve for the magnitude of T1, and actually I'm going to solve for T2 because I have numbers calculated in front of me, and that's going to speed things up just a little bit. Okay, so if I solve for T2 here, what I'm going to get is that the magnitude of T2 is equal to a negative times the magnitude of T1 cosine of 140 degrees all over cosine of 32 degrees. Okay, we're going to take this value, this magnitude of T2, and we're going to substitute into B for the magnitude of T2. Okay, and that's going to allow us to get an equation with one unknown that we can solve for. Okay, so when I substitute this into B, I need a new page to do that. So B now becomes the magnitude of T1 times the sine of 140 degrees plus, and now here I replace my T2. So it'll actually be negative magnitude of T1 cosine of 140 degrees times sine of 32 degrees all over cosine of 32 degrees is equal to 100. And now I can factor out that T1, the magnitude of T1, that leaves behind a sine of 140 degrees minus, and I can kind of rewrite this one, it'll be cosine of 140 degrees times tangent of 32 degrees, since sine over cosine is tangent, and this is equal to 100. Last but not least, I'm going to divide to get T1 in magnitude is equal to 100 divided by sine of 140 degrees minus cosine of 140 degrees times tangent of 32 degrees. And actually, I do want to just recalculate this in case, because I did use different organization. So I have 100 divided by sine of 140 minus cosine of 140 times tangent of 32. And I get that T1 in magnitude is approximately 89.17 newtons. Okay, so I can take that 89.17 and I can go ahead and substitute it in for T2, because we know that from A, T2 in magnitude is going to equal negative T1 in magnitude times cosine of 140 degrees all over the cosine of 32 degrees.
What? I don't know.
So I go ahead and I substitute my 89.17 newtons in here, and this will give me approximately negative 89.17 times cosine of 140 degrees all over cosine of 32 degrees. And I'll calculate that. 89.17 times cosine of 140 divided by cosine of 32. That is going to give me approximately 80.55 newtons. Okay, and so I can use these values, and these are my magnitudes. I can use them to figure out what T1 and T2 are. T1, remember, was the magnitude of T1 times the cosine of 140 degrees, and then the magnitude of T1 times the sine of 140 degrees. So I would need to pop in, let's see, so this is T1 here, and then this is T2 here. So I'm going to pop in my T1 values of 89.17, it's approximate. 89.17 cosine of 140, and 89.17 times sine of 140. And I'm going to get some approximate values there of 89.17 times cosine 140. That is going to give me approximately negative 68.31 for my x component. And then times sine of 140. This is going to be approximately 57.32 for my y component. And then T2, I can come up with as well. it was very similar. We had the magnitude of T2 times cosine of 32 degrees, and we had the magnitude of T2 times the sine of 32 degrees. And T2 we have up here is 80.55, so we have 80.55 cosine of 32 degrees and 80.55 times the sine of 32 degrees. Again, put this in my calculator. My x component is approximately 68.31, and my y component, 80.55 times sine of 32 degrees, is going to give me approximately 42.68. Okay, so we've got approximations. They're not exact values because our angles were funky, but we have been able to come up with exactly what was asked all the way back here a page ago. Find the tensions. That was the last thing that we found, T1 and T2. We could not find T1 and T2 until we knew the magnitudes of each of those. And that was the other thing that was asked for, the magnitudes of these tensions. And so we found them in this second page. We found T1 at 89.17 newtons and T2 at 80.55 newtons. Those should balance out the 100-pound weight. That concludes 12.2. I'm sorry about it having to be in 2 videos. Apparently I have a 1-hour limit on Loom, but we'll make it work. And let me know if you have any questions at all.